Welcome, curious minds. Today we're doing a deep dive into something that's, well, it's quickly reshaping our reality. We're talking about the powerful fusion of artificial intelligence, AI, with extended reality, XR. And this isn't just about, cool new gadgets. It's really a fundamental shift, a shift in how digital worlds are built, how they're experienced, and maybe even how they're personalized just for you. Our mission here is to pull out the most important nuggets of knowledge, the key insights from a whole stack of fascinating sources. We've got recent market analyses, academic papers on designing AR and VR, some really cutting edge research on fluid simulations, and even work from places like the MIT Media Lab.
Exactly.
Mm.
And by looking at all these different perspectives, the aim is to give you a really solid understanding, to see how AI isn't just making things look more real in virtual, augmented, and mixed reality. It's actually redefining how we interact with, well, with both digital content and our physical spaces.
Okay, so let's unpack this a bit. We hear XR thrown around a lot. What exactly is it?
You-
And why is AI suddenly like, oh, it's best buddy?
Right, so XR, it's basically an umbrella term. It covers virtual reality, VR, where you're fully immersed. It covers augmented reality, AR, where digital stuff overlays the real world, and mixed reality, MR, which blends the two.
And traditionally, these relied on what? Preset rules?
Pretty much.
Yep.
Yeah. Traditionally, XR tech used static algorithms, pre-programmed responses. Things were kind of fixed. But what's really fascinating now is the AI integration, specifically things like machine learning, computer vision, natural language processing.
Ah.
These give XR platforms the ability to actually learn. They can learn from how you behave, see patterns, respond in real time.
So it's not just following instructions, it's adapting to me.
Exactly. It's a huge shift.
Yeah.
It means these XR systems can dynamically adapt to your actions, your preferences, maybe even your emotional state.
Yeah.
And the result, the interactions just feel much more intuitive, much more engaging.
Okay, that sounds powerful. Can you give us some concrete examples? How does that real-time adaptability actually play out?
Sure, sure. Think about VR training, for instance.
Mm.
Instead of just running through a fixed scenario over and over, an AI-powered system can actually ramp up the difficulty based on how well you're doing.
Oh, interesting.
Yeah, or it can give you immediate personalized feedback. It might even simulate unexpected events based on your decisions, making it feel much closer to real-world complexity.
Right, not just a canned response.
Exactly. Or take AR. AI makes a huge difference in recognizing objects, mapping the space around you, tracking your gestures. This means those digital overlays on your physical world. They become smoother, smarter, really feel like they belong there. That's huge for retail or, say, industrial applications.
Like those apps where you try furniture in your room, but way better.
Precisely. Much more accurate, more responsive. And then a new MR, mixed reality. AI is really the secret sauce for seamless integration. It lets holograms interact contextually with your actual room, understand where things are, even respond to your voice commands or where you're looking. Think about collaborative workspaces or remote help.
Mm-hmm.
It makes those digital elements feel truly present and responsive. It really boosts the realism.
Okay, so this is where it gets really interesting for me. That dynamic adaptation, it sounds amazing, but maybe a bit much. How do designers make sure these AI-driven XR experiences actually feel good to use? That they don't just, overwhelm you?
That's a great question, and it brings us straight to user experience or UX design. It's absolutely critical here. Designers, especially for AR, focus on maybe 5 core elements that all kind of work together cyclically.
Okay, what are they?
Well, first, there's the environment, considering the real world, the lighting, the space, how digital things will actually interact with physical objects. Then there's movement, making sure transitions feel smooth, natural, responsive animations, accurate tracking, that kind of thing.
Right, so it doesn't feel jerky or disconnected.
Exactly. Third is onboarding, giving you clear, simple instructions, maybe little tool tips right when you need them so you understand how to interact with something new. Fourth is interaction itself, moving beyond just tapping screens to more intuitive things, like spatial gestures, maybe pinching to zoom or swiping in the air, voice commands too,
Making it feel more natural than clicking a mouse.
hopefully. And finally, the user interface, the UI, keeping it clean, accessible, but not intrusive. It should complement the AR content, not overshadow it. Things like transparency, size, responsiveness are key.
It sounds like a lot of thought goes into making it feel almost invisible, like the tech gets out of the way.
That's the goal. Absolutely. Best practices involve things like contextual awareness, the system knowing where you are and what's around you, spatial consistency, and crucially, immediate user feedback, knowing the system registered your action. Plus, constant user testing and tweaking. It's all about designing a balanced experience, one that respects your time, your cognitive load.
Okay, so when they get this right, when the UX and the AI work together, what does it actually mean for us? Where are we seeing this AI-driven XR making a real difference today?
Oh, the impact is already pretty widespread, and it's growing. Take healthcare. Surgeons are using AI-driven mixed reality for incredibly precise visualization during operations. It adapts as they work.
Mm.
Medical training in VR, it can adjust difficulty scenarios based on your real-time performance,
That's a huge leap from textbooks.
isn't it? And AR, in anatomy or physiology education.
Mm.
You can have these immersive interactions with 3D models of, say, the human heart that respond and adapt. It really bridges that gap between theory and practice.
I can see how that would stick better.
Definitely. Then in education more broadly, virtual classrooms, virtual labs, they're starting to tailor the learning experience to each student's pace, their engagement level. There's a survey, I think about 60 students in biology courses using AR. The vast majority found it very effective. The realism of the simulations got super high satisfaction scores, like over 4.5 out of 5. Things like guided tutorials, interactive 3D models. They really value those adaptive features.
So it's not just cool, it actually helps people learn complex stuff more effectively.
That seems to be the indication, yeah. It shifts learning from passive to active adaptive engagement. Elsewhere, manufacturing and engineering. Think AI-powered AR giving real-time guidance, step-by-step instructions, even quality checks during complex assembly tasks.
Like having an expert looking over your shoulder.
Kind of, yeah. In retail and marketing, AR experiences can change dynamically based on your past behavior, your stated preferences, delivering hyper-personalized shopping experiences, and of course, entertainment and gaming. Adaptive storytelling, NPCs, non-player characters that seem genuinely intelligent, environments that react to what you do. AI makes these worlds so much richer and more interactive.
Okay, but it sounds incredibly complex to pull off consistently. There must be some major hurdles, right, to get to this truly seamless future.
Oh, absolutely. A really fundamental challenge right now in the VR space is, well, getting everything to work together smoothly across different platforms. It's a big obstacle. One huge issue is device fragmentation. You've got high-end headsets like the Oculus Quest or HTC Vive,
Yeah.
and mobile options like Google Cardboard and everything in between.
Right, wildly different capabilities.
Exactly. They vary massively in processing power, how well they track motion, screen quality, input methods, hand tracking versus controllers versus just looking somewhere.
So developers have to build for all these different targets? That sounds
Yeah.
inefficient.
It is. It leads to performance disparities. Different devices just have different muscle. High frame rates, low latency. They're essential to avoid motion sickness, to make it enjoyable. But optimizing for a powerful PC often means making big sacrifices to get it running on a standalone headset.
Makes sense.
And then there are the cross-platform compatibility headaches. Developers wrestle with different SDKs, software development kits like the Oculus SDK, Steam VR, OpenXR, plus different graphics APIs like DirectX or Vulkan. All this variance just drives up development time and cost.
So it's a bit of a wild west still. What's being done to try and tame it? To standardize things for us, the users?
There are some really important efforts underway. OpenXR, which comes from the Kronos Group, is a major one. It's an industry-wide push to unify VR development. The goal is a single API that works across basically any hardware or software setup. That saves developers tons of work.
Okay, that sounds promising. Anything else?
Yes. Another really interesting trend is cloud-based VR streaming. The idea is to do the heavy lifting, the complex rendering on powerful remote servers, then stream the visuals to your device. This means less powerful hardware, like standalone headsets or even mobile VR, could deliver really high-quality experiences that used to need a beefy PC.
Ah, so the device you own matters less.
That's the potential, yes. Companies like NVIDIA, Google, Meta, they're investing heavily in this kind of cloud-first model.
Yeah.
It could really help level the playing field and reduce that hardware dependency. Of course, true cross-platform harmony needs ongoing cooperation between everyone, hardware makers, software devs, industry groups.
Okay, let's dig into some specific tech challenges. You mentioned fluid simulations earlier. Simulating something like water or smoke in real time in Immersive, that sounds computationally brutal.
It really is. Real-time fluid simulation, especially on current MR head-mounted displays, MR HMDs, is tough because those devices just don't have desktop-level processing power. These simulations often involve solving complex equations, like the Navier-Stokes equations, which are very demanding.
So how do they even attempt it?
Well, one interesting project called FSMR took a clever approach. They used an efficient algorithm, position-based fluids, or PBF.
Yeah.
But, and this is the key part, they did the heavy computation remotely on a nearby server. Then only the resulting particle data, basically a cloud of 3D points representing the fluid, was sent over Wi-Fi to the MR headset, like a HoloLens V2, just for rendering.
Outsourcing the hard math. Did it work?
It made a big difference. Performance on the HoloLens jumped from about 8 frames per second, which is pretty choppy, up to around 25 FPS. Still not the 60 FPS you'd get on a powerful PC, but a massive improvement for a mobile MR device, making it actually usable.
That's a neat trick. Now, how does this relate to interacting with physical stuff in a virtual space, bringing digital content into our environment more tangibly?
Right, that connects to some interesting earlier work like the virtual reality responsive workbench. This wasn't full immersion, but more like an interactive tabletop VR system. It was designed specifically for really fine-grained interaction with virtual objects laid out in front of you, not navigating a huge world.
How did it work?
It projected a stereo image onto a table. You wore shuttered glasses, like early 3D glasses, and the system tracked the head and hand movements of one person, the leader, to update the 3D view and allow interaction.
Okay, a sort of interactive 3D workspace. What were the interaction methods like back then?
They tried a few things. Direct manipulation using a pinch glove, which felt quite intuitive for grabbing things. It was wired, physically tethered, and could sometimes block your view of the virtual objects. They also used speech recognition for commands, but you had to use very specific phrases. And they had a sort of virtual laser pointer, a wand, but that involved learning button combinations. Each had its pros and cons,
Yeah, trade-offs everywhere.
Exactly. And this kind of early exploration directly informs the modern concept of hybrid user interfaces, or HUIs. The idea here is to combine your MR headset with other physical devices you already have around you. Your smartphone, a tablet, keyboard, maybe even your smart TV.
So not just relying on the headset's controls.
Precisely. Each UI is aimed to compensate for the weaknesses of just using the headset while playing to the strengths of these other devices.
So leveraging the best of both worlds, or maybe all worlds you have access to, what are the big opportunities there? How does that optimize things for you?
Several key ways. First, reachability. Instead of straining your arm to poke virtual buttons floating in midair, you could map controls to your phone or smartwatch, which are right there, easy to reach, familiar to use, and offer tactile feedback.
Makes sense. Less arm fatigue.
Exactly, which ties into ergonomics. Using physical devices like a keyboard for typing or a tablet for drawing can be way more comfortable for longer tasks than holding your arms up. People talk about the gorilla arm effect. The HMD still presents the main visual content at eye level, which is great for visibility, but the input comes from a more comfortable source. Right. And third, visibility. Sometimes you need to see really detailed information or complex data. Displaying that on an external screen, like a big monitor or TV, often gives you better resolution, better contrast, more sheer space than the headset display alone.
So you can have your main MR view, but supplementary info pops up on your tablet or monitor.
Precisely. It's about distributing the interface intelligently.
But I imagine juggling all these devices, making them work together seamlessly, that must bring its own set of challenges.
Oh, for sure. It's not simple. One challenge is just knowing the availability of devices, what's actually nearby, what can each device do. A mouse is great for precise 2D pointing, a touchscreen for direct taps, and even who owns the device. Can a personal phone be used as part of a shared work interface?
Good point. Privacy implications, too.
Definitely. Then there's the complexity of interaction cost calculation. How do you figure out the cost in terms of effort, time, potential for error of using one device versus another for a specific task? A tablet might feel different, offer different accuracy, impose a different cognitive load than a smartwatch, for example. You need models to quantify that.
Wow. Okay. That's getting complicated.
It is. And finally, there's the cost of switching between devices. Every time you shift your attention from the headset view to your phone, then maybe to a keyboard, that involves visual shifts, maybe changing your posture, switching input methods. It adds cognitive overhead. It can make things harder to discover, harder to learn. So the switching cost also needs to be factored in to design truly optimal hybrid interactions.
Okay, so this fusion of AI and XR, it's clearly changing interfaces, how we interact with machines, but it feels like it's touching something deeper too, like human interaction itself, maybe even our thinking. Where's the really cutting edge stuff happening there?
That's a really insightful point. And yes, research is definitely pushing into that territory. You can look at groups like the Fluid Interfaces group at the MIT Media Lab. Their whole focus is on designing systems for essentially cognitive augmentation, enhancing human capabilities through better human AI interaction.
Cognitive augmentation, like making us smarter with tech.
In a way, yes, or at least more capable in certain contexts.
Mm.
They're working on projects like Large Language Model for Mixed Reality, LLMR. The idea is to use natural language, just talking, to create and modify interactive MR scenes in real time.
Just describe what you want to see and it appears.
That's the vision. Another project, Attentive View Plus XR, is fascinating. It combines AR headsets with brain-computer interfaces, BCIs.
Whoa, BCI.
Yeah, to actually measure your cognitive state. Things like how engaged you are, where your visual or auditory attention is focused, if you're imagining something, even your underlying intent.
So the system could literally know if you're paying attention or confused or about to do something just by monitoring brain activity.
That's the direction it's heading. And if you connect these dots, these developments are leading toward AI-driven interfaces that are truly adaptive. They could dynamically modify themselves based not just on what you do, but on your behavior, your preferences, even your physiological responses measured through sensors. Think emotion detection, eye tracking, speech analysis, making systems truly context-aware and, well, maybe even emotionally responsive.
Wow. As these systems get smarter, more integrated, literally designing the UI around you moment by moment, physically and virtually, it really does raise some big questions, doesn't it? What should we as users, as designers, be thinking about as this future starts to arrive?
Absolutely. It pushes us into really important discussions. Ethical questions, for sure. What does accessibility mean when the interface itself is fluid? How do we manage the blurring line between physical and digital reality? The key, I think, is ensuring these incredibly powerful tools are developed thoughtfully to genuinely enhance human flourishing and aren't just, the next hype cycle.
That's a crucial point. Well, we've covered a lot of ground today, from just understanding what AI-driven XR even is, to the nitty-gritty of designing the UX for you. We looked at its impact across industries, the headaches of device fragmentation, and some really clever solutions like those fluid simulations and this whole idea of hybrid interfaces.
Yeah, I think the big takeaway is that AI isn't just adding polish to XR. It's fundamentally transforming it from maybe a static visual layer into something more like a living, learning ecosystem. It's unlocking personalization, efficiency, realism on levels we haven't seen before. It's really reshaping the future of how humans and machines interact pretty much everywhere.
So as you go about your day, maybe mull this over, what happens when your digital experiences literally start adapting to your blink, your focus, maybe even your mood? How might that change not just what you learn, but the very way you learn it? What new skills could you develop, and what new questions might you ask when information itself is designed to flow around you and with you?